Okay, welcome Year 11. I'm really glad that you found the video solutions, and what I'm going to go and just quickly do is read the first part of the booklet cover. Okay, so the Year 11 half-term homework, which says this. In the booklet, you've got exam questions from the topics listed below that you've covered in previous years. So the topics that we've selected here is not the content you've done this year with me, you've done this in previous years, and they're all exam questions, okay, on topics that you'll see quite a lot on papers. It says if you get stuck on the questions, use the video solutions, which is where you're at, so that's really good, on my channel, MC Maths Tutor. Now, what I'm going to go and do is for every topic, so number 1, simultaneous equations, that will be one video. Section 2, solving quadratics, will be video 2, just to make the video not too long. Okay. Now, below that, it says if you wish to revise the topics covered from this term, so this term, guys, with me, you've done transformations, algebraic fractions, vectors, vector proof, the nth term of quadratic sequences, and just other sequences. It says you can find exam questions with solutions at Maths Genie. This, which I'll show you guys in a second, just to make sure we can find this definitely. Now, this is a fantastic resource. It covers the whole GCSE curriculum for all exam boards. Okay, so it will cover you for AQA. And it just means that if you want to practice a particular topic, you can do that. So just before I get into this video solutions, let's just say you want to recap the nth term of a quadratic sequence under grade 8 and 9 in Maths Genie. So the way to find that is you're going to go on to Maths Genie. So let's get Google on over here. Okay, so Maths Genie, type it onto Google, Maths Genie, search it up. The first link is what you want. Okay, and then you want to select GCSE revision. Okay, and there's usually a few adverts, but just close that all down. And it goes from grade 1 all the way to grade 9 with all of the content. Okay, now let's just say you wanted to revise the nth term of a quadratic sequence, this one here. The website's amazing. You've got videos on that particular topic, so if you want to just learn the topic again, you can watch the video here. But then what's really good is you have exam questions here, which is really useful. So you can just get what I recommend you do is you get yourself a notepad or just some sort of paper where you can write things down. And you don't even need to print off the questions. You can just work straight from your screen, from your phone if you need to, or your laptop, and practice on your bit of paper, okay? And then also you've got solutions there. So you've got questions with solutions. Okay, so you can mark all of your work. And all the solutions are handwritten, so you can kind of understand it quite clearly, I think. But let's just say you wanted to go through something else. You know that, for example, you've struggled previously with grade 5, okay, grade 5 SOHCAHTOA. So trigonometry, you've got exam questions there that you can practice. Okay, so you can maybe go and do some questions here and just practice going through them. Again, you've got solutions as well, so you can mark all of your work. And the solutions are really easy well, they're quite clear to follow. They're handwritten. It's not a mark scheme, so they're quite good to follow. So that is that. Now I'm going to get back onto this video, which is, oh, that's the wrong thing, which is looking at simultaneous equations to begin with. So let's begin. Section number 1. Okay, solve these simultaneous equations. Now, the aim of the game with this is to eliminate either x or y by getting the coefficients before x and y to be the same in one of them. Now, for this one, y is the same in both of them. You've got 2y. And actually, I'm going to go and label my equations 1 and 2, first of all. So let's go and call these equation 1 and equation 2. Let's just drag over so I've got some more room. Perfect. Now, to eliminate these two y's, I've got to take them away, because 2y take away 2y is 0. Now, I'm going to make a big thing about laying out my work really clearly, showing the working. I'm going to go and do equation 1 and take away equation number 2. Okay, so I'm doing the top equation, take away the bottom equation. 7x take away 3x is 4x down here. And then importantly here, 2y take away 2y is 0, so they eliminate. And then looking at the number part, that's all going to be equal to 100 take away 48, which gives me 52. So 4 times what gives me 52 is going to be 13. If I divide through by 4, x is going to be equal to 13. So this is my first solution. X is equal to 13. Now, to find the value of y, I've got to substitute in. Okay, sub x equals to 13 into either of the equations. Doesn't matter, you get the same answer. Probably choose the one where the numbers are a little bit smaller, so probably go for equation number 2 in this one. It doesn't matter though. So I've got 3x where x is 13. So 3 times 13, I'm going to write it out in full. 3 times 13, add 2y is equal to 48. And now from here, you just got to go and kind of clear everything up. So 3 times 13 gives you 39, plus 2y is equal to 48. I want to get this 39 onto this side by taking it away. So 2y is going to be equal to 48, take away 39, which gives you 9. Okay, 48 take away 39 gives you 9, good. And then to find the value of y, okay, I've just got to go and divide by 2. So y is going to be equal to 9 divided by 2, which gives me 4.5. So this is my y solution. Okay, I've solved the equation. X is 13 and y is 4.5, so I'm going to just write it below. X is equal to 13 and y is equal to 4.5. These are my solutions. Okay, and actually, right, I should have written it down here, but there we go. Perfect. Now, just to show you guys, you can check that your solutions are correct. I'm actually doing this without a mark scheme, so I'm assuming that what I'm doing is correct, but we can always check our working. So let's go and do that. So over here, we're going to go and check our work really quickly, just to make sure that everything's good. So if these solutions are correct, x is 13, y is 4.5, these equations should be satisfied. So I'm just going to go and check by putting in x is 13 and y is 4.5 into equation 1. So 7 times 13, 7 times 13, add 2 lots of y, which is 4.5, should be equal to 100. Now 7 times by 13 is going to be 65 and 26, 85, 91, isn't it? That's going to give you 91. And we're going to add on to that 2 by 4.5, which gives you 9, which gives you 100. So it does make sense. Okay, it is correct, which is really good. Okay, that's question number 1. Question number 2, very similar. Solve these simultaneous equations. Now this time, the coefficient before x and y are both different. Now you've got to get one of them to be the same, and you can choose. Now because I'm looking at x's are both positive, it's probably going to be easier to deal with x. So let's go and call these equations 1 and 2 again. Equation 1 and equation 2. Now 2 and 3 both go into 6. Okay, so that's the lowest common multiple. So I'm going to multiply the first equation by 3 and the second one by 2, so that the 2x and the 3x become 6x. So timesing equation 1 by 3, timesing every single term by 3, well, that's going to go to 6x minus 15y is equal to 39. Timesing equation 2 by 2, so you're timesing every term by 2, that's going to go to 6x plus 8y being equal to 16. Now again, you could go and label these equations, let's go and call them equation 3 and equation 4, because they are new equations. Now we can go and eliminate x quite nicely. Okay, now you can choose to do either 3 take away 4 or 4 take away 3. I'm going to go and do 3 take away 4, because the n number will be positive still, so 3 take away 4. So 6x take away 6x is 0, minus 15y take away 8y will give you minus 23y. So minus 23y is going to be equal to, so I did equation 3, take away 4, and then equation 3, so 39, take away 16, is going to give you 23, isn't it? So that's going to be equal to 23. So minus 23 times by something gives you 23, well, y must be equal to negative 1. Y must be equal to negative 1. So that is your y solution. Okay, there we go, done. Now I've got to go and find x. I'm going to go and substitute in y is negative 1 into each of the equations. Now if I go and put it into equation number 2, just because the numbers here are all positive, it should be a little bit easier, to be honest. So let's go and look at this one. So 3x add 4 times y, where y is minus 1, is equal to 8. So I've got 3x. 4 times by negative 1 is minus 4, is equal to 8. I'm just going to go and solve the equation now, so go and add the 4 and divide by 3. So 12 divided by 3 gives you 4. So x is going to be equal to 4. And that's my solution for x. And just really quickly, okay, I'm going to go and check my working over here. Okay, that should be fine, but we're just going to go and quickly check our work. Let's go and put these values of y is -1 and x is 4 into equation 1, and it should be satisfied. It should be equal to 13. So I've got 2 lots of x, where x is 4. Take away 5 lots of -1. Does that equal to 13 or 8? And you've got -5 times -1 is +5, and that does indeed equal to 13. So it makes sense. Good. That's that question. Question number 3 is here. Now this is a sort of question where it's classic exam practice, because this is a classic simultaneous equation question. Okay, just hidden in words. Okay, so it's just saying you've got 4 chocolate bars. I'm going to call that X for chocolate bars. I'm just going to do it in red. 4 chocolate bars and 3 packets of mints. I'm going to call that Y. Costs is equal to 470. 5 chocolate bars, 5x, add 1 packet of mints, add 1y is equal to 450. Work out the cost of a chocolate bar and a packet of mints. It's just recognising its simultaneous equations. Okay, on the first equation, equation 1, let's call it, you've got 4 lots of chocolate bars, add 3 packets of mints is equal to a cost of £4.70. On equation 2, we've got 5 chocolate bars, 5x, add 1 packet of mints, add y is equal to £4.50. Now we just solve these in the same way as before. Now the x coefficients are different, and the same with y. If I times equation 2 by 3, I'm going to get 3y in both cases. That's going to be really useful. So let's go and take equation 2 and multiply it through by 3 to give me 15x plus 3y is going to be equal to £13.50. Let's go and call this one equation number 3. So now looking at equation 1 and equation 2, I'm going to go and do equation 3, take away equation 1, because now the 3y's will cancel out. Let's go and do that in a different colour. Equation 3, take away equation 1. So 15x take away 4x is going to give me 11x. And then importantly here, the y's are going to eliminate. These are going to cancel out with each other. I've got 13.50 take away 4.70, which is going to give me 950, 880. Okay, so that's going to be equal to 880. I'm just going to go and double check this on my calculator, so we're not making any silly mistakes. Let's go and get this onto the screen. So there we go. I've got 13.50 take away 4.70 is equal to 880. Good. Now to go and find x, now, I've got to go and divide £8.80 by 11. So I'm going to go and do 8.80, divide that by 11, which gives me 80p. Okay, so that's my first solution, 80p. So x is going to be equal to 0.8, 80p. That is my first solution, where x is the chocolate bar, so that's my my first answer. Chocolate bar is going to be in pounds, 80p. Now to go and find y, I'm going to go and substitute in, sub in x is equal to 0.80 into either equation. Let's go for equation number 1. Doesn't matter which one it is. So I've got 4 lots of £0.80 or 0.8, add 3 lots of y is equal to £4.70p. So £4 times by 80p is 4. 8, 16, 24. Sorry, it's 320, it's 3.2. Add 3y is equal to £4.70. Let's go and take away that £3.20 from 470, which is going to give me 150. So 3y is going to be equal to 1.50. Divide by 3, so y is going to be equal to 50p. And that should be it. So we've got 80p and we've got 50p. Remember the pack of mints was y is 50. So there we go. These are the solutions. And again, we're just going to quickly check our work, because I'm actually doing this without a mark scheme, which is probably not the best idea. But it's good, because it means we have to check our work like we would do in the exam. So let's put in our values into equation number 2. Okay, this one here, 5x, add y is 450, and it should make sense. So 5 lots of 80p, add 50p, does that equal to £4.50? And I can tell it does, but we're going to show that. So that's going to be £4, add 50p, does indeed give you £4.50. So it makes sense. Yeah, we've checked our work. Good. Question 4 is exactly the same sort of thing. And sorry, the formatting here is not the best, is it? Because it actually goes on to the next page, but we'll be fine. But again, it's recognising that it's simultaneous equations. We've got 3 adults. I'm going to call that 3x. Add 2 child tickets, 2y. Okay, so 3x add 2y is equal to 46 quid. You've got 1 adult, 1x, add 2 children is equal to 24 quid. So you've got 2 equations here to work out the cost of an adult ticket and a child ticket. So equation number 1, let's go and do it over here. We've got 3x add 2y is equal to 46. And equation number 2, we've got 1 adult ticket, x, add 2 child tickets, 2y is equal to 24 quid. Now this one is quite easy to do because the y's I can just get straight into eliminating by doing equation 1 take away 2. 1 take away 2, so I've got 3x take away 1x gives me 2x. I've got 2y, take away 2y is nothing. That's going to be equal to 46 take away 24 is 22. So 22 goes down there. Therefore, dividing by 2, x is going to be equal to 11. So the cost of an adult ticket is going to be £11 in context, so 11 quid. And then to go and find y, we're going to go and substitute x is equal to 11 into either of the equations. Let's go for equation number 2. So I've got x, which is 11, add 2y gives me 24. Take away the 11, 2y is going to be equal to 13. So y must be equal to 13 divided by 2. In money, £6.50. Okay, and these are my solutions. Now we're going to check our work, of course, as always. We're going to go and put in our values. We're going to check our work by putting our values into equation number 1 this time. Let's just do that. So 3 lots of 11 add 2 lots of 650 should be equal to 46. So 33 add 13 does indeed equal to 46. So I'm looking good. Perfect. Okay, question number 5 is over here. And the question says this. On the graph of y equals 4 minus x, sorry, it says the graph of y equals 4 take away x, which is this over here, is shown for the values of x between minus 2 and 5. What does that mean? Well, x is over here, that's the x-axis, minus 2 is here, and x is 5 is over here, which you can see, right? The graph goes from minus 2 to the point 5. Now, just quickly, to make sure that makes sense, this is coming from, because it's a straight line, isn't it? That is a straight line. This is coming from y is equal to mx plus c. Whenever you see a straight line, this is what I'm thinking about. Does it make sense? Yeah, because that 4, okay, is the y-intercept at c. They've just switched the c part and the x part around. Okay, so that makes sense. The 4 is over here. And you've got a gradient of minus 1. Okay, m is minus 1. So you're going down by 1 across by 1 every time. Yeah, so the axis here is a bit different, but that's 3 there, isn't it? So across by 1, down by 1, across by 1, down by 1, across 1, down by 1. So it makes sense. Okay. It says on the grid, draw the graph of this, y equals to 2x minus 5 for the values of x from minus 2 to 5. Now, you could do this in different ways. Okay, in intervention, someone drew a table of values here, and that's what I'm going to go and do first of all. But I'm just going to show you different ways of doing this. So from minus 2 to 5, okay, all you need to do, right, to plot a straight line, you only need to do it for 2 points. So if I draw out a little table here for x and y, okay, just choose 2 points and make them quite easy. If I choose x to be 0 and x to be 1, I can find the y values really easily. Putting them into this here. When x is equal to 0, and I put it into my equation over here, well, y is going to be equal to 2 lots of x, which is 0, take away 5, which is going to give you minus 5. Okay, that's 1. This here is 1 coordinate. 0 minus 5 is a coordinate. Okay, so 0, negative 5. When x is 1, we're going to have y is going to be equal to, so y is equal to 2 lots of 1, 2 lots of 1, okay, take away 5, which is 2 take away 5, which is negative 3. So when x is equal to 1, y is negative 3. Okay, and that there is another coordinate, so 0, sorry, so 1 and negative 3. So if I go and plot these two coordinates onto my grid, okay, and join a line going through them, that will be my straight line. So let's go and do that. So 0 minus 5 is going to be, let's going to zoom in so we can do this a bit more clearly. 0 minus 5 is going to be there, okay, and then we've got 1 minus 3 is going to go there, isn't it? Okay, now if I get my line going through these points here, okay, it must go through them, there we go, and it says it has to go from -2 to 5, so let's just kind of keep going with this. There we go, that's the first part. Ooh. Okay, so there we go. Good. And then I've got to go extend it a little bit longer, so that's just kind of increase the length of it down to there. Okay, so there we go. That's my line. That is my line. Okay, and does that make sense? I'm just going to do a bit of checking. Sorry. 2 by -2 minus 4 minus 5. Yeah, that looks okay. Just looking a little bit inaccurate here, but that's fine. That is -9 there. Perfect. But that's it. Right, I've just used 2 x values to give me 2 coordinates and then put a line going through it from -2 all the way to 5 over here. Okay, I've done that. Now, alternatively, I could have recognised that, well, this here is, of course, from y equals to mx plus c, where m is the gradient, remember? So m is the gradient, and also c is the y-intercept. Okay, now it makes sense because, well, -5 is down here, so that does make sense. And the gradient is 2. That means for every 1 I go across, I'm going up by 2. 1, 2. Across by 1, up by 2. Across by 1, up by 2. Okay, so if I choose a bit of an easier point, if I start here, or even here, across by 1, up by 2. 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 Yeah, it also makes sense. You could have done it by doing that method. That's that part done anyway. I'm actually going to go and label my line I've just drawn, y equals to 2x, take away 5. Now part B says, use the graph to solve 2x minus 5, okay, which is the line I've just drawn in. This line here is equal to 4 minus x. And 4 minus x is the line they gave you. Now, where they're equal is where they intersect, which is this point over here. Okay, and this point is at the coordinate 3, 1. So that's it. So it's going to be 3, 1 is where they intersect. Now, they might ask for a particular format here. Okay, right, it's just saying x equals to, well, the x value is just this point here. Okay, that's the coordinate where they meet. Okay, but we're just looking for x here, and the x value is just equal to 3, because that's the x coordinate, that's the y coordinate. So x is going to be equal to 3 on this one. There we go. Question 6. Apologies, I just recognised this. Sorry, this question 6 is actually in the wrong section. It should be under solving quadratics, but I'll go through it anyway. Okay, it's just a little mistake, it's fine. It says write down the solutions, the 2 solutions of this. So this is not simultaneous equations, apologies. I've just put the question in the wrong section. That's fine. The 2 solutions here of this, well, y plus 2, bracket y minus 4 is equal to 0. Well, you've got 2 linear equations here. You've got the first one, which is when y add 2 is equal to 0. Take away the 2, y must be equal to minus 2 is 1 solution. And similarly, you've got a second equation here, which is y take away 4 is equal to 0. Add the 4 over, y is equal to 4. So that's the other solution. Okay, minus 2 and 4. Question 7. The last question on simultaneous equations is the diagram shows 2 regular hexagons, so every single side is the same size, with the baselines extended. Work out the values of x and y. Now this is actually simultaneous equations again, where you've got to initially form an equation. Now if these are the same hexagons, it must be true that this angle here, y plus 4x, must be equal to 120 degrees. So that's going to be the first equation. Y at 4x must be equal to 120 degrees, equation 1. And equation 2, similarly, must be, well, y minus x must be equal to 60. Okay, so y take away x must be equal to 60. There we go. Okay. That should be fine. So now we can eliminate either x or y. Now, y we can get rid of really easily by taking them away. So I can go and do equation 1 take away 2. Equation 1 take away 2. Which will give me, well, 4x take away negative x. So I've got 4x take away negative x means 4x plus x, which is 5x down here, being equal to 120 take away 60, which is 60. Dividing by 5, x must be equal to 12 down there. That's the first solution. Now let's go and find y. Okay, let's go and find y by putting x equals to the equation. So let's put x equals to 12 into equation number 1. Why not? So I've got y add 4 times x, which is 12, equals to 120. So y add 48 equals to 120. Take away, got what am I writing there? Sorry, that was a bit of a mistake. Sorry, y add 48 is equal to 120. Take away the 48, which is going to give you 72. And that's it. Okay. And these are your two solutions, which we're going to go and double check again. And it should be also true that, well, this is a straight line. If y and x are equal to 12 and 72, these should add up to 180. That's a good way to check it as well. So let's go and do that. Okay, so y add 4x. If y is 72, add 4 times x, well, plus 48. Okay, that's going to give you 120 over there. Y is 72. Take away x, which is 12, gives you 60. And 60 add 120 gives you 180, which is a straight line, which makes sense. So there we go, guys. That is the simultaneous equation section done. Hopefully it was useful and you can mark your work, and any questions you can comment in the comment section below. And we'll get on to solving quadratics in the next video. Thank you.